In this video, we're going to try to prove that arctangent of 1 over x is equal to pi over 2 minus arctangent of x for x positive. We have already proven this result using calculus. Today, we're going to prove it using some trick. Okay? So, I have written it this way so I make it easier for you to work. Okay? So, we start from here. Okay? And the key ideas is that we don't know, in fact. So the arctangent of 1 over x is going to be between these two values. Okay, so it has a limit of pi over 2 as x goes to 0 from the right, and minus pi over 2 as x goes to 0 from the left. So this is the arctangent of 1 over x. Okay, so in our case, so we note this one, we're going to use it. So if we define theta, a new variable, as the arctangent of 1 over x, and since x is bigger than 0, theta is going to be in this interval 0 pi over 2, 0 not included. Okay, so theta is going to be in 0 pi over 2. Okay, so we have a bijection between theta and this value here. Okay, now since theta is in pi over 2, we can take the tangent. Okay, we can take the tangent of theta. Okay, let's take the tangent of theta. In this case, we have tangent of theta is going to be tangent of arctangent of 1 over x. So here the arctangent of 1 over x is between 0 and pi over 2, as we see here. If we take x as positive, therefore it's defined. Okay, so therefore these two functions, okay, or we can do it another way. Okay, we can because we need x, we don't need the 1 over x to conclude, because we can say this is equal to x. Okay, but since this value here is between 0 and pi over 2, and this is between 0 and pi over 2, this one is going to be equal to 1 over x. Okay, we can change it if we don't like it. Okay, so this is 1 over x. Okay, and from here we can get that x is 1 over tangent of theta. But this one is not helpful because we don't want a 1 over x or 1 over tangent. We want to have a linear relation between them. The key is that we can rewrite the tangent theta as this is going to give us cosine of theta over sine of theta. Okay, but to bring this one to the tangent, we need to use some trick identities that we know. So we know that sine of pi over 2 minus theta is cosine theta, and cosine of pi over 2 minus theta is sine of theta. If we use that here, we're going to have sine of pi over 2 minus theta over cosine of pi over 2 minus theta. So from here we get a relationship between x and tangent. So here we get x is equal to tangent of pi over 2 minus theta. Okay, we have assumed that theta is between 0 and pi over 2. Okay, but what about pi over 2 minus theta? If we try to do it, we're going to have minus theta is between minus pi over 2 and 0. And if we add pi over 2 to both sides, we're going to have pi over 2 minus theta is between 0, 0. So this is pi over 2 minus theta. It's going to be between 0 and pi over 2. And this is good. Okay. So if it's like that, we're gonna have, if we take the arctangent of x, we're gonna have arctangent of x is gonna give us arctangent of tangent pi over 2 minus theta. So since this one is between, this value here is between pi over 2, 0 and pi over 2, so we have this one here, we have the arctangent of tangent of pi over 2 minus theta is equal to pi over 2 minus theta. Okay? And therefore we know that theta is equal. So we have arctangent of x is equal to pi over 2 minus theta. And we know that theta is arctangent of 1 over x. And therefore we can take our value here. We can get the arctangent. So that's all we need, in fact. So we can get the arctangent of 1 over x is pi over 2 minus arctangent of x. And that's what we need, in fact. That's what we need to prove. So it's the same way of saying it. So it's this way. The key idea is this relation here. We need to have these values between 0 and pi over 2 because x is positive. Okay? And we know that if we restrict ourselves to 0 pi over 2, tangent or arctangent are inverse of each other. That's the key. That's why we get this one here. Because if we are outside of this range, we can't have this relation. We can have something similar. Okay? But the key is that the arctangent and tangent have to be, this arctangent has to be, its values has to be in minus pi over 2, pi over 2. But since we are taking the positive part, it has to be between 0 and pi over 2. And the tangent, this angle has to be between 0 and pi over 2. And when it's between 0 and pi over 2, we have two inverse functions. That's why we have this value. And this is how we get this one here. There is another way we can do, okay? So we can see that pi over 2 minus arctangent of theta, of x. Arctangent of x is always between minus pi over 2 and pi over 2. But since we are working with the positive x, so this one here is going to be between, so arctangent of x is going to be between 0 and pi over 2. Because for x positive, okay, for x positive, if we take the minus, we're going to have arctangent, it's between minus pi over 2 and 0. And adding pi over 2 to both sides, we have 0 pi over 2 minus arctangent of x is between 0 and pi over 2. Okay, so we can take from here, we can take the tangent. Okay, and once we take the tangent, we can apply the rules. But we have this pi over 2. We can apply the that tangent of a minus b is tangent of a minus tangent of b over 1 plus tangent a tangent b. But this pi over 2, that makes the problem. That's why we have to start from here. Well, anyways, it's a good problem, and the algebraic way, this is how we do it in using trigs. We can do it using just angle measures, and I think we're gonna do it next time.